class is linked list. Normally, linked list is a linear data structure. Linked list is a linear data structure. It is used for storing collection of data. Normally, linked lists are used for storing the collection of data, huge collection of data. And linked list contains two parts, two nodes. First part is data part, and second part is link part. Data part, it contains the elements, okay, and the link part contains address of another node. Okay, this is how the linked list look like. Okay, first of all, this is head. It stores the address of this variable, and like that it stores the address of, it's like a pointer. It stores the address of one variable of another. Okay, it's like a pointer. And but in the last one, it always points to the null value. Okay, the last one, it always points to the null value. And the main important points in linked list are, it can shrink or grow at the time of execution. Linked list can grow or shrink at the time of execution, and the last elements always points to null, as I told you before. And we can create or make as much as the linked list we can require. How much we can require, that much we can create, and it does not waste memory space. Linked list does not waste the memory space, and the successive elements are always connected with pointers, as I told you before. Okay, now there are three types of linked list. First one is single linked list, second one is double linked list, and third one is circular linked list. Let's discuss about single linked list. Okay, now single linked list. In single linked list, normally SLL, okay, single linked list, it is a collection of data elements, and in each element in single linked list, it is represented a node, and each node consists of one or more data fields. Okay, and second point is, this is an important point, one address field which stores the address of the next node. Means, let's take here, these are single list here. It stores the address of this variable, and it stores the address of this variable, and is always null value. And some operations in the linked list is, there are three operations we can do in single linked list. Those are, first of all, creation, second one insertion, and third one is display. Okay, these are the, or we can write it as traversing, or deleting, or inserting. Okay, those two are same. Okay, now time complexity of single linked list is n, and space complexity of single linked list is 1. Okay, now we will discuss about double linked list. The main and core advantage of double linked list is that in double linked list, if we are given a node in the list, it can be navigated in both sides. Okay, let's take here from here. In double linked list, we can if we insert a node, we can navigate from this side, and we can also navigate from this side. From both sides we can navigate the node. And in double linked list, we can delete a node even if we don't have a previous node address. In single linked list, if you want to delete this node, we have to get this address from the next node. But in double linked list, if you want to delete this node, we can directly delete this node. We don't have to we don't need the address of the next node. Okay, and the major disadvantage in the double linked list is that insertion and deletion, the process of insertion and deletion takes a much longer time than the single linked list, and each node requires an extra pointer, requiring more space. Double linked list requires more space. Okay, and the time complexity of double linked list is n, and space complexity of double linked list is 1, and it has some traversing techniques, insertion and deletion. Now we will discuss about circular linked list, the final linked list. Now, the major difference between these three is in circular linked list is in single and double linked list we have an endpoint. Okay, now single and double linked list we have an endpoint. Okay, but in circular linked list we does not have any ends. Okay, we does not have a end. We does not have an endpoint. While traversing the circular linked list, we have to be careful. Otherwise, it will be infinite. Okay. When we are doing the circular linked list, we have to do very carefully. Otherwise, it will be infinite loop. Okay. These are some traversing techniques: insertion and deletion. And circular linked list can be used in the implementation of. We can use a circular linked list in the implementation of stacks and queues. Okay. And time complexity of circular linked list is n, and space complexity of circular linked list is 1. Thank you.